When we speak of glaciers in general, or climate change in general, it is important to note the effects that climate is having on glaciers, whether they are advancing, staying the same, or retreating. The situation can obviously be more complicated in that each mountain and each glacier is a unique entity experiencing different conditions. Snowfall and temperatures can change from year to year. And so we need to look at the overall pattern. And it would be deceptive to use one or two exceptional cases to try to hide the greater overall pattern. For example, in May of 1980, Mount St. Helens erupted, and this obviously caused the melting of all of the glaciers which had previously covered the mountain's tip. Starting in the winter of 1980 to 1981, new glacial ice appeared, and glaciers have since grown on Mount St. Helens. This is obviously an exceptional case. Mount Rainier's Emmons Glacier is the largest glacier in the contiguous United States. It was receding rapidly in the 1930s, and the glacial basin once held a much more extensive Emmons Glacier until fairly recently. In 1963, a large rock slide from a neighboring ridge, Little Tahoma, covered much of the glacier and provided insulation which had not previously been there. As a result, Emmons Glacier actually began to advance while other glaciers in the area were retreating. Since the early 2000s, the Emmons Glacier has once again begun to retreat. These are examples of individual unique scenarios which affect an individual glacier. So while it is very important to speak of overall trends dealing with glacial ice, one should not use a deceptive argument pointing to one or two exceptional cases as contradicting the overall trend.